17. How much work is done by the force lifting a 0.1 kilogram hamburger vertically upward at constant velocity 0.3 meters from a table? Okay, so let's jot down all the given information we have here. We want to know how much work, so let's just remember what work is, right? Work has a unit of joules, right? So all our units are in joules. So at the end we better make sure that our final answer has those units. And they want to know how much work is done by the force lifting a 0.1 kilogram hamburger. So this hamburger is being lifted. There's a force that's doing that lifting. We don't know what that is right now. I'll just put F there. And the hamburger has a mass, and that mass is 0.1 kilograms. So we'll jot that down. And it's being lifted vertically upward at constant velocity. So velocity is constant. I'm just going to put V is constant. What does that mean if V is constant? It means there's no acceleration, right? I'll jot that down as well. No acceleration. Or you could say A equals 0. And it's being lifted 0.3 meters from the table. That's a distance, right? Meters. So the distance that it's being lifted is 0.3 meters. Alright, so let's draw a picture, or better than a picture, a free body diagram of what's really happening. So our hamburger is being reduced to a dot here. That's our hamburger. And there's this upward force on it. That's this F here. I'm going to call that the lifting force. And that's totally arbitrary, by the way. When I make up little subscripts like that and I say, hey, I'm going to give this an L, the reason I'm doing it is because I want to make that separate and distinct from the force of gravity, which is also acting on it. Notice we haven't drawn the table here. There's no normal force because it's not resting on the table, so the equal and opposite reaction to the force of gravity is not the normal force. What's actually happening is the force of gravity is trying to pull the hamburger down, and there's a force, FL, the lifting force, being exerted that's opposite, and these two forces are opposing each other. Okay? And now to actually start to solve this, you may be tempted to write Newton's second law, which is a good idea. So we can say F equals ma, right? But what is A in this situation? It says velocity is constant, so there's no acceleration. So A must be 0. So if A is 0, that means the force is 0. Well, what force? This is the net force, right? And I didn't write that down on purpose because a lot of times people forget. It's the net force that equals mass times acceleration. So the total acceleration is 0. The hamburger is being lifted, but it's being lifted at a constant speed. No acceleration, no net force. So if the net force is 0, then what must that mean about the lifting force as compared to the force of gravity? They must be exactly equal. That's why there's no net force on it, because these two are equal and opposite and they're canceling each other out. So let's set them equal and we can actually start to solve. So the lifting force is equal to the force of gravity. Okay, so now what is the force of gravity? Well, normally we write F equals ma in general, but specifically for gravity we write F equals mg, because g is the acceleration due to gravity. So let's make that substitution for Fg. So now Fl equals mg. And we know m and g. The mass was given to us as 0.1 kilograms. And I'm going to be a little sloppy here and say 10 meters per second squared. You can say 9.81 if you want to be particular. Okay, so the lifting force is 10 times 0.1 is 1 Newton. That's the units. Kilogram meters per second squared is 1 Newton. So there's a 1 Newton force being exerted on the hamburger to lift it with a constant velocity. And what were we being asked to find? They wanted us to find the work being done when exerting that force. Well, what is work? Work, there's a few different kinds of work. There's different work when you eventually get into electricity. You can do work. It involves voltages and electric charges and things like that. As you flip through your equation sheet, which is included with the test, you'll want to find out which work equation is the right one. It's the one that has to do with work and energy, where, and this is the simplest formulation of work. It's the first one you learn. Work is a force exerted over a distance. So force times distance is work. and it's that lifting force that's being exerted on the hamburger that we're interested in. That's a 1 Newton force. And what distance is that force moving the object over? Well, it's moving it over a 0.3 meter distance. So ultimately the work is 0.3 Newton meters. And a Newton meter is the same as a joule. So work and energy have the same units, they have joules. So it's 0.3 joules. And that's your best choice. That's choice 3.